organize your workflow so that you get more headspace. So Dropbox Dash is a universal search product that is powered by AI, and it helps you in finding, organizing, sharing content, and also while providing in-depth access control on your content as well. You can ask follow-up questions and whatnot. So of course, there's a lot more AI features coming up soonish. Now let's deep dive into how we went about building this, like what we learned building these AI features on Dash. So RAG, this is not a new thing to anybody here. So first choice to solve these problems obviously was from your user. That's the retrieval part. And the second part is where generation happens. This is where the latest and greatest LLMs kind of fit in. You use one or multiple LLMs to generate the final response in response to the user query, right? Pretty simple, right? Well, not quite. So complexity comes in like how many options there are in building your RAG systems. So this is like extremely oversimplified picture of what retrieval options are available today, right? So think of it like this. So most common one is, let's say you build a vector index and then you have embeddings there and you allow to do semantic search. When a query comes in, you do semantic search and you fetch chunks of content and then you feed it to the LLM, right? And there's this other option where like a lot of people stick to traditional IR just because we have like built those systems already and we are like very good at that. And then followed by chunking and re-ranking on the fly to kind of zoom in on the best possible choice of content, right? So with so many options to choose from, how do we pick the best one, right? As with all good things, there are trade-offs. Even in picking retrieval options, there is no surprise there. So, and a company that is like doing something new, like small companies or pre-PMF or prototyping phase, when you're building a new product, it's hard to choose all of them. You can't just have it all, right? So let's take an example. So let's say you want to build a low latency system because you want like to impress your users really quickly, but you end up having to sacrifice on quality. Though that is changing now with like smaller models becoming more capable and whatnot, it's still a challenge. Now, if you want data freshness, you would want to be like fetching latest and greatest data like without any delays in syncing and whatnot. Now that has its own challenges of scale and also being able to be low latency. Now, if you have the budget, of course, you can do more than one thing. So cost is kind of like the overarching factor of it all. So deciding like the priorities in these factors will help us kind of pick the right retrieval options for you. So the next part of RAG, obviously, is generation. And generation is like, this is the simplest view you can ever get. It's basically you feed in your relevant chunks into LLM, you ask the question or do some prompt magic there, and then get the response out in the way, a format or style that you want the response to be delivered in. So how do you pick the best LLM that works for you, right? So we did a lot of work in kind of evaluation and picking the best system, but I won't be going into so much detail here because I want to focus more on agents part of the talk. But this is like, in a gist, what we did was we picked some public benchmarks. So in this case, these three that I've listed here. And we also hand-tuned some metrics. We did some human annotation, a lot of LLM as judge kind of metrics. And then this kind of, so this evaluation that the graph that you see, first I wanted to show you the graph in detail, but it's just, it's a never ending thing. So every day there's like there's new model coming up and we're continuously evaluating, and it's, basically we use this to give us like the best options possible for us to offer with our product. So did we do everything right? Are we production ready yet? Well, let's see. So we explored our options, we benchmarked, we built an end-to-end system, we did all kinds of testing, and now launched to production, right? So are we ready? Well, this is, unfortunately, this is where the RAG system kind of starts to fall apart. So let me tell you what I mean by that. We'll take a look at all the challenges that we kind of had to face. So I'm going to focus on three high-level challenges that we kind of had to face here with enterprise. So the main thing is this data source diversity problem. So what I mean by that is your enterprise consumers tend to have data from stored in many different applications. So understanding where, what type of information is stored is really key. Let me explain what I mean by this with some examples, right? So these are just some apps that any knowledge worker will be, referencing. This is, I mean, again, I'm oversimplifying it to the core because I heard from somebody while talking at GTC that some startup had like 2,000 SaaS applications that they had to deal with or something. And this is just insane, the number of applications that we have to deal with, where your data sits. You have email messages, task management systems, bring in pager duty even for on-call for engineers, right? Calendar, email, and whatnot, right? So when in this system, now identifying the right source is challenging. So let me walk you through this example. So somebody comes and says, show me notes for tomorrow's all hands meeting. And what does this bring in your head? Like, so somebody says meeting notes, I'm like, okay, maybe they're talking about summary of a meeting that has happened. But then since the query kind of says tomorrow, it is something maybe somebody has hand curated notes and I want to see that. So you can't really fixate on saying that, no, I want to show meeting transcripts. You have to know where the data is coming from. So solving these kind of problems required some domain knowledge and also contextual information, right? So the other thing is, the second challenge is the main one, which is data fragmentation. So now not only is your data divided, is present in multiple data sources, it's also kind of present in fragments, right? It's not, one place does not have all the information. So let's take this example here. So somebody wants to know the progress of projects of their team for Q1 OKRs, right? So now this is a complex query, but when you look at it and if you try to throw RAG at it, you'll see that we are going to bump into limitations. Like, how do you know who my team is? Who is the team? We have to consult org chart for that. How do you know team's progress? You have to consult Jira or other task management systems for that. And OKRs, maybe depending on the company culture, you're stored it in a document or you're stored it in some Airtable or something like that. So it's not as simple as, just bring a bunch of chunks, throw it into LLM and let it do the magic, right? And the third one, this is a very important one too, which is data modality. Like, how do you handle multiple, videos and images and whatnot? So this example right here is basically, it's a very typical scenario, right? You want to be able to understand graphs. You want to be able to understand slides, images, and whatnot. So how do you do that? So is traditional RAG sufficient to handle all these cases effectively? Well, partly some of it, yes, it can kind of cover some use cases. So I'm doing a demo here. This is a kind of a thing in words. Right now it's not out there yet. So what this demo is going to show is basically an implementation of multimodal RAG. This is not agents just yet. And what I'm going to do in this demo is, let me play it. So here I'm pulling up an old GTC presentation, which is PDF with a bunch of pictures and nothing else, right? Just pictures. Now I'm asking Dash to summarize it, and we got a nice and succinct summary. And then I can ask a follow-up based on one of the slides, which is talking about these imaging companies, and this is all in pictures. So this is possible thanks to some of the VLMs that we have today. And so RAG can do these things, but can we do even more? Can we do whatever we talked about earlier? Can we do data diversity, fragmentation, and multimodal all in one? Now, this is where we come to the next section of the talk. And I want to spend a lot of time talking to you guys about the agents work that we've been doing. So what are AI agents? In just the last 5 days, as to what AI agents are and what they're capable of doing. So I don't know if we can actually have one definition. These are just like, I just did a search and pulled up the top 2, and this is just a couple of them. But one thing they all kind of have in common is this. They all agree that agents perform tasks autonomously with little to no human intervention. So I'm going to keep that as my, North Star for defining what agents are, right? So this right here is our interpretation of what an agent is. and into tactable steps. And then this plan is then executed inside an execution engine. And while doing all this, we are consulting tools or APIs and data sources and a lot of different LLMs. Now, let me show you an example of how this agent kind of plays out for this example. So this was the example that I took in the beginning. So show me notes for tomorrow's all hands meeting. So first thing you would want to know, if you give it to any human assistant also, they would do this, right? Any human being would, if you give this task to, they would do this. So you break it down into steps. So the first step is try and understand, okay, which time window are they talking about? It's tomorrow in this case, right? And the second step would be to look for meetings that are titled all hands, right? In the time window that we extracted. And the third one would be to look for attachments or links that are present in the calendar event to see if there are, notes present in there, right? Now, how does this actually play out is we don't generate the plan in natural language. We generate it in a domain-specific language. In our case, it is Python, as you can tell. So let's zoom in on the first black box over there. So there are certain parts to we call it DSL statement, or it's basically like a single line of Python instructions or a first step in this plan, right? So if you look at it, there is a variable name, search time window. There is a type, which is time block. There is the time extractors, which is like a class, or we call it context. And then followed by that is a tool or a method which says get time window for tomorrow, right? So as you see, next step will take in the output of the first step, which is search time window, and feed it as an input to the next step, right? So we are fetching a meeting using meeting helpers, and the method's name is get meeting with title, and then you fill in, the LLM fills in the slot, and then we basically get back the meeting. And the third step, and so on and so forth. So basically we get the final output, which is notes, which is of the type, a list of documents, right? So now you might be wondering, how does LLM know all this weird syntax that we have put together? So the way we do this is with few short prompting. We basically have, every agent has its own set of like instructions, or how you break down queries into some known methods. And this, as you can imagine, this is not solvable by RAG, right? It's a complex task for RAG to be able to solve. You're doing multi-step processing, and you're kind of going back and forth and talking to multiple data sources and doing some processing on top of the data that you retrieve. So I'll go into further detail as to now how will this whole thing execute, right? So once you have a plan like this, we send it to our execution engine. So our execution engine, it does a bunch of things. So it's going to look at each of these statements and see, hey, is this method implemented in its known repository? If it is implemented, then great, it gets executed in our custom Python interpreter. I'll get to that in just a bit. And if it is not implemented, then we go back to LLMs and ask the LLM to define that method. And we all know LLMs are kind of good at writing code in limited context. If we give it like, this is the definition, this is what I want it to do, we are able to basically generate this. So it's not possible for us to anticipate all possible, combinations or variations of methods, right? Like it's a tool, but then like how you call it and what are the extra parameters that you want to give, and so on so forth. And like maybe you even want to do like post-processing on top. So these kind of unanticipated cases, what we do is we dynamically generate code, as I talked earlier, with the help of an LLM. So I'll show an example here. Before I start playing this, this problem is very interesting to me, and I've been working in NLP for over a decade now, and like I think my final, master's thesis was, not thesis, but one of the projects was to implement a time phrase extraction and resolution problem. So back then we were doing with regexes and classifiers and whatnot, right? So basically a phrase comes in like, tomorrow, next week, or, December 24th or something, and then how do you transfer that language into an actual absolute timestamp, right? So that is the time resolution problem. So here I'm doing a demo of how an agent can solve this for us. So on February 4th, I asked this question to one of our agents, which is capable of doing time phrase resolution. So I say first day of next week. What I want is, this is like a calendar agent for work, so it is aware of like working hours and stuff. And I know it's too hard to read, there's a lot of text, but I can tell you what's going on there. So it generated a plan, and the first day of next week itself was not, there was no method that knew how to do first day of next week. And that method got generated on the fly, and then we were able to kind of resolve it to the next Monday that came up after 4th, which was on 10th of February. So keep in mind that when we write code that we then feed into LLMs, the kind of code that you write has to be LLM friendly, right? So the same rules of human readable code kind of apply. So when you want your colleagues to read your code that you have written, or people that come after you to come and make changes to the system, you want it to be user friendly, right? So you give meaningful names for methods, meaningful names for variables, maybe add comments with like descriptions and stuff. So this is the same thing, but even more important in this case, because we are now feeding that as a prompt to LLM. So your coding also kind of becomes prompt engineering in this in this scenario, right? So you have to be very aware of what is going to get fed into the LLMs, and you have to make sure that you're not saying variable A, variable B, and so on and so forth, right? So the LLM generated code. So our security team was no different. They were like, what are you guys doing? Why are you running randomly generated code from LLM? So our solution to this is basically was building a custom Python interpreter. So what our interpreter does is basically it's an in-house from the scratch based on Python interpreter. It has a set of allowed or actions. Basically, the idea here is that instead of taking already built Python interpreter and like blocking certain use cases, saying hey, I will not allow you to use system library or OS library, so that you don't like kind of expose security vulnerabilities. What we do is we just don't even implement that. Like it's just, if the code says import OS, it just won't work, right? So this is our solution. So basically, you can't execute code that is not built into the system, right? So that's the thing. So this kind of causes a bunch of failures, of course. Like there are cases where LLM really wants to import that OS, but we're like, no, you can't. So those systems are going to fail, and there are other mitigation strategies for that. But this is basically why we ended up building a custom Python interpreter to keep it secure. Now, the next thing we'll want to have, LLM code, or basically anything that is like agentic. You kind of think of it as, hey, I'm sending this information to LLM is giving this back. How do I write a test around it, right? So we have good news for you. Because of the strong typing that we have, it's kind of makes it predictable. We know what the input and what the output for each of the step is, and we kind of know what the input and output for a whole plan is. So this makes it easier for us to write tests, right? End-to-end tests, unit tests, and whatnot. So strong typing, and it's also easy to develop with. So you kind of know, like if you have a contract with the client and say, hey, I'm going to send you all this information, you kind of know what exactly the types are, right? So if they're expecting a document, they know exactly what fields are there in there. And so this strong typing kind of helped us quite a bit in achieving these predictability, bringing predictability into the LLM space, right? So this is kind of how we build our test plan. So one of the examples, this is a write test manually, right? So basically we have around like 300 test cases. We just went over all these scenarios, and we have like kind of expected input and output. So we built our test system around this. And so whenever you make a change, you kind of need to run all this. So let me tell you that when you're working with LLMs, let's say you add a new example for your agent to learn from in your few shot prompting, it's going to most likely change what happens to the others. So these tests are kind of helping in catching that. So if you you add a new scenario tomorrow saying for maybe risk scheduling is a new thing that I add and it wasn't there before, then did it affect scheduling? Did we break? So these kind of regressions are easy to catch with these kind of tests that we have, and really grateful for those. So I think I spoke really fast. I'm coming to the end. So I'm super excited to be here. I can tell you, this is still a new space, and we're really pumped to be working on this, and we want to keep improving and learning more. But our multi-step orchestration does take us a long way there. But does this mean that RAG is gone and we should never use it? No, of course not. Most of our use cases which involve like simple information retrieval tasks require, you can just do RAG and it's super quick, no harm done. It works well for most cases. Now, the question is, how do you kind of route, right? How do you know which particular style or which kind of agent you want to execute for, answering a incoming query? So we tried these things, and there's so many more. So intent classification is when you basically the query comes in and you kind of say, okay, this is as we have seen from put a model there, and that kind of decides. We have seen these kind of use cases before, and we send this to agent or we send this to RAG, and so on and so forth. And then you can even make an agent do the routing. So agent is aware of, I think this is a RAG problem, so I'll send it to that. So that's like a slightly more smarter model at the helm instead of a pre-trained classifier that we would kind of deploy there. And parallel execution is a safer option, right? You kind of try both, and then in the end pick based on, as I said earlier, your agent will fail if it didn't work out. So you kind of pick the one that passed, and then there may be a more intelligent model that makes this decision in the end for you to pick which one to show. So this, so what did we learn process, right? So this, it's been a journey for us, and we have learned a ton. This slide is probably not doing justice to all the things that we have learned, so I didn't want to put any more text on a slide. But the main thing is enterprise Gen AI or even small businesses Gen AI, right? So you're building a product for knowledge workers in businesses. You kind of need to think a lot about data and data issues around diversity and modality and fragmentation and stuff like that. And building LLM agents has also been a pretty interesting journey for us, and we went through multiple iterations of to bring it to where it is today. And you can't just take any model and it'll work out of the box. Like, so for example, if you build an agent for GPT, you can't use that on Llama models, for example, right? So because each models require a very specific way of writing prompts that the models are able to understand. So don't underestimate the power of prompt tuning. Even in the era of agents, we kind of have to either hand tune or use some libraries that help with prompt tuning, right? Hallucinations are still a problem, as I said. Like, LLM thinks that it can do whatever it wants, right? It just generates sometimes code that doesn't compile or types that don't exist. Things like that. So these are some problems we are still trying to solve. And the trade-offs that I mentioned earlier are completely real. If you want a high-quality system, you are going to end up sacrificing on latency, and it's always a game of cat and mouse. You have to keep balancing. We built like super high quality system first, and then are you going to make your customers wait for a minute or longer? Probably not. They don't have that kind of patience, right? You want to get your information quick and go. So for those cases, it's you kind of have to make a compromise. It's a slider. You say, okay, this level of quality is good, this level of latency is tolerable, and so on and so forth. So multiple LLM calls are always good. We really want to make more calls to kind of, break those failure cases, that the edge cases where LLM generates hallucinated code or, something doesn't work out. But it's a game of catching up with latency that we just have to kind of deal with. So what's coming next is these then conversations might come up, and then like self-reflection in agents. So we want to push the barriers on both the product and the kind of system that powers it. We are looking into fine-tuning LLMs to actually go and do this task really, really well. We are also thinking of multiple languages, and that kind of brings us to which models will work for multilingual languages, multilingual support, and so on and so forth. We are just, just starting here. We'll keep chipping away at this problem, and really excited to be working on this space in this day and age, and like just the innovations that everyone here is probably working on is just inspiring. And yeah, please watch us, and hopefully we'll show something more interesting. Thank you.